Equilibrium example 5. Examples 5 and 6 are going to apply the rule that we talked about back here. Let me go show you that rule. This rule here. If the reaction can be expressed as the sum of two or more reactions, K for the overall reaction is the product multiply the equilibrium constants for the individual reactions. Okay, so we're going to apply that here. So what are we trying to get? This is our unknown value of K. We know the value of K for these two. So like we did in Hess's law, we're going to call it A and B. And then for A, we're going to focus on something in A that we see in our unknown. I would do the NO. I have NO in my unknown, and I have NO in my A. So in order to get NO on the proper side, trying to match it up to the thing I've circled in yellow, I need to reverse A. And I have to and need to, so I multiply by a 1. Looking at B, before we look at B, I would go ahead and do that. So I took A and I reversed it, right? And I multiplied through by 1. Now I'm going to focus on B. So what in B would I focus on? Well, what in B do we have in B and our unknown? NO2. Okay, so then I'm going to focus on that. And I know to get NO2, I'm going to keep it forward. And I have to and need to, so I'm going to multiply by 1. So I'm going to bring that down. I just lined up my arrows to make things a little easier. So I brought B down just like it was. Now I'm going to either eliminate, reduce, or sum like items. So here you see N2 gas completely cancels because they're one on each side of the equation. So they subtract away or reduce away. I also will have one O2 on the right and two O2s on the left. So this one O2 will reduce the two O2 down to 1. Giving me exactly the pieces I needed in my unknown, 2NO gas, going to an O2 gas, going to 2NO2 gas. So I know I've set this up right. Now I'm going to apply the rules to the K that I applied when I looked at A and B. So for A, I said reverse, so I had to take the K for A and put it underneath 1. And it's to the first power, so I did not raise it to anything. And then for B, I said to keep it forward and multiply by 1, so I brought it down here. And then to get the final, remember, we're not going to add them, we're going to multiply the factors. So I'm going to take the 2.4 to the 30th times 1.0 to the negative 18th, and my final answer is 2.4 times 10 to the 12th. For 5B, a new problem. Here's my unknown. And here is my A and my B. So I made these A and B. So I'm going to look at A. What in A is unique to A that I also see in my unknown? I would say NO. So what do I do to get NO on the side I need for my unknown? In A, it's a product. I need it to be a reactant, so I need to reverse. And I need to multiply by 1. Why? Because I have to and I need to. For it, and then I write the equation doing that. So I took my A and I reversed it and multiplied by 1. So here's the A and the forward, and then I reversed it down here. What can I focus on in B that's in my unknown? NO2. To get NO2 in the proper position, I need to reverse it and multiply through by 3, because I need to go from 6 down to 2. So I multiply by a third. I apologize. Multiply by a third. And then I'm going to do that and write the equation below. So if you notice here, I put these, I had to reverse it, so 3 times a third is 1, and 6 times a third is 2, and then 6 times a third is 2 on this side. Now we're going to either reduce, eliminate, or sum alike items. So here we have N2 gas canceling because there's 1 on each side, so it eliminates. And here I have 2 O2s and 1 O2 gas. So this 1 O2 gas will subtract from this side and leave us with 1 O2 gas. 2 minus 1 is 1. So then I look to see what I have left for my reactants. 2NO gas, yes. Oxygen gas, yes. Going to 2NO2 gas. So now I know I've set it up. I got my unknown. Now I know when to apply the rules of K to what I did to A and B. So I reversed A, so I have to put the value of K underneath 1. And I multiply by 1, so no raise to the power factor here. I reversed B, that's why it's under 1. And I also multiply by a third, so I have to take the K value of B and put it under 1 because I reversed it, and raise it to the 1/3 power because I multiplied through by a third. I get these two values, and then to get my final answer, I'm going to multiply those two values And this is what I get, 1.2 times 10 to the 12th. Again, go through the math and make sure you understand how I got these values using your calculator. Okay, example 6 is similar to example 5, except for you don't have the unknown equation given. You have to write it. So this is the unknown equation we're going to write. It says formation of 1 mole of NOBr from its elements in the gaseous state. So I know I'm going to form, that means makes NOBr, and then it says it's formed from its elements in the gaseous state. So N2, diatomic, plus O2, the other element of the three. O2 is diatomic and Br2 is diatomic. We need to balance it. So I had to put a 2 here to get it balanced. But I have to set this to 1 mole of NOBr. So now I need to adjust for that. That means I multiply through by a half. So this is set to what it's asking for, the formation of 1 mole of NOBr from its element states. Now I need to get the value of K for this. I'm going to make these be my A and my B. So for A, what do I see in A that I see in my unknown? In A, I have N2. So to get N2 in the proper side, I'm going to have to reverse it. And in A, I have 1. So in A, I have 1. This is A and this is B. I have 1 N2, so I have to multiply through by a half. And in B, what can I focus on in B? Br2, perhaps. Okay, and so what am I going to do to get that on the proper side? It's already on the proper side, but I do need to multiply through by a half, because I need a half and I have 1. So I applied that reverse multiply by half to A here, and forward multiply by a half to B here. I eliminated NO, leaving me exactly what I needed, 1/2 N2, 1/2 O2, 1/2 Br2 going to NOBr. So now I'm going to apply the rules of K I'm going to apply the rules to K. So it's 1 over 1.8, because remember that we knew K for A was 1.8 to the negative 30th. So 1.8 times 10 to the negative 30th to the half power. Why is it under 1? Because I reversed it. Why is it raised to the half power? Because I multiplied by the factor of a half. I get this value. Double check to make sure you can do this math to get this value. For B, I kept it forward. That's why it's not under 1. But I did multiply by a factor of a half, so I should raise the value of B, which we got from up here, to the half power. When I do that, I get this. And then I'm going to take these two new values of K I got, and I'm going to multiply them and get this answer here. This is 0 power in case you're having trouble reading that. So once I multiply my new values of K, I get that value.